Hello everyone, welcome back. Today we're going to start our first lesson on chapter 1.1, which is called coordinate vectors. Our course actually talk about multivariable calculus, but in order to try to understand how when you deal with multiple variables, what does it actually mean? I mean, remember, math is created to try to make sense of the world around us. It's not just some crazy people have nothing better to do and other than to create crazy problem for students to learn. It's actually try to describe the world around us. And one of the very simple things that you realize is that in our world, we are allowed to move in three different directions. And if each of the directions represent a variable, then now we are talking about something that have at least three variables involved. But the problem is most of the math that you have learned so far are only concerned with two, x and y. So now in order for us to actually make the jump from what you have been learning for the past 10 or 11 years to what we're going to learn now, we have to have some way to describe what's happening between multiple variables. And so to do that, we're going to start our year with linear algebra, a study on how to deal with multiple variables and what does it mean by having more than one variable or more than two variables in most cases. So to start our unit, I'm going to have to define a very important term, and this is what we call a term called vector. So what is a vector? So a vector from a geometrical standpoint is basically this, is a geometrical object that has the following two quantity to it, that has both a direction and a magnitude. And usually, and that's not the only way to define a vector, but I think a vector defined as a geometric object is easier for people to understand. So how do you represent a vector? A vector is usually represented by an arrow. An arrow would give us both of these things that we need to define, a direction and a magnitude. So we usually would draw a vector this way, which has a beginning point and then point to some other value. So in this scenario right here, this spot right here is our starting point. And wherever the arrows end, that would be the ending point. So in order to properly define a vector, you must basically define 2 points, a point where it starts and a point where it ends. And then the arrow kind of indicate which way it goes. So therefore you could have a vector that have the same, identify the same 2 points, but just go in opposite direction. And then this length right here would be equal to what we refer to as the magnitude. And this entire thing would be referred to as a vector. So how do we name a vector? A vector is usually named using a lowercase letter. So in this case, this vector could be referred to as vector A. But the problem is the following. So these are very little things, but very important that you pay attention and understand, because these are standard notation that we're going to be using throughout the course. And so if you don't pay attention to them, you find out that you get yourself all confused. The problem with a lowercase letter is that we often already use a lowercase letter to represent a single variable. But we are learning what to do with multiple variables. So we have to have an indication to indicate that this lowercase letter does not just represent one variable, but in some cases represent multiple variables. And therefore, we will draw an arrow over it. Oops. And this referred to as a vector A. And if you simply just have A without an arrow on top, that's usually referred to as a scalar A. What's the big difference between a vector A and a scalar A? A scalar A usually represents a single variable, while a vector can represent a collection of variables. So in this case, we represent multiple variables. So make sure you understand the differences between these two notation. Now, to confuse the matter some more, and of course, we are in a math class, so therefore things have to get more confusing because otherwise it's not going to work. Your textbook doesn't use the arrow to indicate a vector. The textbook uses a bold letter to represent a vector, while regular letter to represent a scalar. So make sure when you read your textbook, pay attention to that. However, on my notes or on my test, all vectors will have an arrow on top to indicate that they are the vector. So that way it will help you understand it. And some of you might be already thinking, isn't that the same symbol in geometry for using array? And you are correct. It is the same exact symbol because array, technically speaking, would be like basically just like that. Now, however, there is one key difference between array and a vector. Array has no magnitude, has no length, because by definition, array extends forever. A vector does have a length, so a vector is more like a segment in that aspect, but more directed segment. Good. So because remember, we are basically using vector to kind of represent variable. So then how do I actually indicate how many variables do we have? So next week we'll talk about is the following. So if a vector is representing a single variable, we would say that this vector is technically a scalar. So a scalar is basically one single variable, and in this case we will say for us we will actually say that this single variable will represent one real number and unknown real number. And therefore in this case we would say that this single variable, the scalar, exists on a number line, which we're going to call that R. But with fancy R with a double line on it, and some of you might recognize that that is the symbol for a set of a single set of real numbers, and that is exactly what it is. And on this number line, we're going to say this is my negative infinity, this is my positive infinity. We always define some kind of point of reference. Let's say in this case, I'm going to say, here's 0, which is our point of reference. And then we can now represent a vector this way. Let's say I want to represent a vector, the vector 3. So then what happened is we would define a vector by doing the following. We would define, let's see if we can do this. All right, there you go. The vector 3, and therefore this will be my vector. This vector have one direction, and pointing in the one direction, which is point to the right. And it has a magnitude of 3. It started at 0 and at 3. Is that the same exact vector as the vector that go to -3? No, it will go opposite direction, but have the same magnitude. And in this case, we're going to call this vector vector x. In this case, x equal to 3. Notice there's no arrow on top of the x because in this case, this vector technically is one-dimensional and therefore is the same as a scalar. So I'm just going to use a regular scalar notation, which is just a lowercase letter to represent it. So what happens if I now want to represent more than one variable? And now when you represent more than one variable, you are now defining what we call a vector. And so how does that work? So let's see what happened to, let's say we have a vector in or with, maybe I should say with 2 variables. And both of them represent unknown real number. Then how are we going to represent it? So in this case, algebraically, a vector is represented by an order list of numbers. An order list of numbers. What does that mean? Well, it means the exact same thing that you probably learned back in 7th grade, where you have to list xy coordinate as an order pair. And that's basically what it means. So, example, with two variables, we are now going to define a vector. We're going to define a vector. So this vector, I'm going to call it vector x. And notice now I have arrows on top because now represent two, more than one single variable. So, and then I'm going to say this vector x is 1, 2. So now how do we graphically represent this vector? So now because we now have two variables, each represent an unknown real number, we now have to represent our vector with two real number lines. So instead of 1, we now have 2. And by convention, we all can orient our number line the same way. The one that's horizontal, negative infinity on this side, positive on this side. For the vertical one, we use the bottom to be negative infinity, the top to be positive infinity. And now let's say I want to look at this vector 1, 2. So how does it work? So then the horizontal one usually represents the first number on the vector, while the vertical one usually represents the second number on the vector. So then for this vector x, which is equal to 1, 2, basically represent 1 on the first number line and 2 on the second number line. So let's say here will be where 1 is, and let's say here will be where 2 is. Then therefore this vector basically identify a vector that starts as 0 and end at 1, 2. Okay, so this vector is now referred to as vector x. Now, something very important to understand is the following. Remember, every vector always define a beginning point and an end point, and then the vector kind of tell you how to go from one to the next. In this scenario right here, our vector has a beginning point right here, which is 0, 0. And have an end point right here, which is 1, 2. The end point or the beginning point could be represented differently using different notation. As a matter of fact, in geometry, you probably remember learning that we use capital letter to define points. So in this case, we could define this point on the bottom, the origin, which is O, and then this point at the top to be the point X. Ooh, probably not a good idea because you can't tell the difference between. So maybe I would say this point is capital A. Is there a functional difference between the point A, which have a coordinate 1, 2, and the vector x, which have the value 1, 2? The answer is yes, definitely. But in this scenario, in this picture, they are functionally the same because of something that you haven't learned yet, which we're probably going to learn later on toward the end of chapter 1. More importantly, how would I describe this scenario where we put two real numbers together to form this space to draw this vector? We'll refer to it as r square, or sometimes just read it r2, because I don't like to say r square because it's not like exponential, but it's kind of because you're kind of making the dimension, making more variables involved. But I usually read it r2, but if you want to read r square, you're perfectly fine. Good. And you can think that similarly, if you want to have what happened to a vector with 3 variables. A vector of 3 variables would be in what we refer to as R3. And the vector would represent now by 3 numbers. So the vector in this case, I'm going to once again call it vector x, will probably have 3 numbers in it, maybe like this, 1, 0, -4. Now, as you suspect, in some cases, these two variables in the top picture, right here, would be referred to as x and y. So in 3 variable, what would we call them? Well, so let's go do this. So in this case, we sometimes call this the x, and sometimes we call this the y. So in 3 variable, what are we going to talk about? Well, what are we going to call them? In 3 variable, we will actually call them x, y, and z, like you think you would. And the problem is, just like with the 2-dimension, we almost always call the horizontal one x and always the vertical one y. We rarely do the opposite because that's just how people do it. Same thing happened to 3-dimensional. But 3-dimensional, there are way more orientation that we can consider. So for us in this class, we are only going to consider 2 different orientation when we deal with 3 variables. And those 2 orientation will be the following. Oops. All right, there you go. 3 orientation. So you have the axis that go to the right, axis that go straight up, and this axis kind of go out of the board toward you. So you have to use a little imagination a little bit because I cannot obviously draw a picture that point out toward you. So this would be a z-axis, this is our x-axis, this is our y-axis. This is one orientation that we use, and the reason why we use that because the horizontal axis stays the x, the vertical axis stays the y. So therefore, it kind of looks like the xy plane that we usually use, except that it points out of the board in the z direction. So that's a very common orientation that we use. A second orientation that we're going to use is this one instead. Oops. Where we have the one pointing out to be x, the one to the right is y, and then the one going up is z. In this scenario, is also very popular because we basically use the xy as the floor that we're standing on, while the z is like the height direction. So that's also a very common way to do the 3 variable R3. And yes, we can do 4 variable, 5 variable, and on, but we won't be able to draw those. So most likely in this class, you'll be drawing in R2, 2-dimensional, or most commonly referred to as XY planes, or 3-dimensional, which commonly referred to XYZ space. Now, we already talked about how to name a vector, but inside a vector, there are quite a few numbers involved, so it's also important to learn how to deal with them. So remember, a vector is named by using a lowercase letter with an arrow on top. Or in the textbook, bold lowercase letter. Okay? Then how do I refer to the number inside a vector? So take a for instance, I have this vector right here. I'm going to call it vector A. And vector A is going to have 4 numbers in it. So therefore, first thing is that we know that this vector A exists in what we refer to as R4. Why R4? Because there are 4 numbers in it. Therefore, when I represent it, I have to represent by 4 different real numbers. Therefore, it has to be an R4. And so what happened to each of these numbers inside? Well, each of these numbers inside is going to be identified by the following. The first number is often referred to A sub 1. The second number, A sub 2. The third number, A sub 3. The fourth number, A sub 4. Is there a surprise to use this notation? You shouldn't be surprised because that is the same exact notation that we use when we talk about sequences and series. In this case, we usually name each of the number inside a vector using the same letter as the name of the vector, but using a subscript to indicate the position. In this case, a sub 1 indicate the first number. A sub 2 represent the second number. A sub 3 represent the third number. A sub 4 represent the fourth number. Also, another thing that's interesting is that a vector sometimes can be written not horizontally but vertically. And when it does that, then we just don't use the comma to separate them. We just kind of have them one on top of the other. So that's a vertical representation of a vector, and that's a horizontal representation of a vector. Now, all of these seem to be pretty simple until realize that, notice I actually didn't use this notation for a picture right here. This notation right here is often referred to as a subscript notation. And in a subscript notation, we use a subscript to indicate the position of the number inside a vector and the name of the vector as a way to show association. So in this case, a sub 1, a sub 2, a sub 3, a sub 4. That's called subscript notation. The problem is that outside of the math, most people don't use the subscript notation. The reason because they use a much more common notation called XYZ notation. As a matter of fact, that's what I just used right here, as well as right here, where I call this X and Y instead of using subscript. So the idea is that you can use XYZ notation to indicate position within a vector, but only up to 3 R3. But face it, for most other discipline, R3 would be probably all they need. As a matter of fact, one of the most common application of vectors would be in physics, where they only deal with three-dimensional movement. But for us, of course, in math, we deal with any dimension as needed. So we could talk about something that's in 12 dimension or 27 dimension or higher. Now, but that doesn't seem to be an issue because then I just call XYZ. What's the big deal? The problem is, what if you have multiple vectors involved? So in this scenario right here, where we're using subscript notation, it's pretty easy to say, let's say if I have a second vector, then I'm just going to give the second vector a different name. I'm going to call the vector B. And vector B could have 4 other numbers in it. Maybe I'll do like this. So now what do we call each of these numbers? Well, the first one is going to be B sub 1, B sub 2, B sub 3, and B sub 4. That makes sense. Now the problem is, what if now we talk about XYZ notation? Now that becomes an issue. And if you want to write it down for yourself, you should. We kind of can use XYZ notation for something that happened in R4. The 4 variable is actually referred to as W, and they put after Z. But I would recommend if you go up to past 3 dimension, and you have to use the 4th vector in R4, then you will use subscript notation. It's just nice and looking, but you will see some problem in a textbook that uses XYZW notation. Okay, so that's I'm just going to call this. So we also could have something called XYZW notation, where in this scenario right here, in R2, we will call our vector using XY. In R3, we'll call our vector XYZ. And then in R4, please don't get confused. We don't put W in front of X, but we do XYZW as the 4th one. And it seems simple until what happens we have multiple vectors involved. What happens if we have 2 or 3 different vectors involved and we want to identify their variable inside. Well, then that become a little confusing. So be careful with it so that you don't get yourself all confused. So suppose I have the same exact two vectors I just used. I have vector A, which is 1, 0, -3, 9. And also vector B, which is 3, -2, 7, 10. So how am I going to call each of these numbers now? So before in the subscript notation, I just call all of them A, but they just have a different subscript that indicates is the first coordinate, or second, or the third, or the fourth. And I'll call all of these B. But in the XYZ notation, the first number is always called X. But there's a problem now. There's an X right here, but there's also X for this one. Then what do we do? So most common way to do that is we call this number X1 and this number X2. And then now this number is the second number in the list, and that's always the Y coordinate. We call it Y1, and this one would be Y2, and then this one would be Z1, and this one would be Z2, and then this one would be W1, and then this one would be W2. So why is that confusing? Well, it's confusing because of the different ways to use a subscript. In the previous example, in the subscript notation, the subscript are used to indicate placement within a vector. And all the number inside vector will have the same destination. They all have the same letter. In the XYZ notation, the subscript is not used to indicate placement, but instead indicate which vector it is. Like in this case, all these have a subscript 1 because it come from A, vector A, which I guess we refer to as the first vector, while these all have a subscript 2 because they are all come from the second vector. As a matter of fact, in some cases, you might see me use X sub A, Y sub A, B sub Z sub A, W sub A, which will probably be a little clearer as to what is referring to. But of course, in some cases, it's just harder to write letters than numbers, and you have to write a whole bunch of them. It's easier to just say 1, 1, 1, 1, 2, 2, 2, 2, and on. But that's the different ways to use subscript. And for us, both notations will be used, and you're going to have to, based on the context of the problem, understand how it's being used. Of course, the biggest problem here is that if the vector name is technically A, X, Y, and Z, then it can be very confusing as to how you actually identify them. And so be very careful when you read the problem and read the vector. And when the problem indicate X1, X2, or Y1, Y2, things like that, you have to make sure you understand that how are they actually using them, so you don't get confused. Now, to some of you might actually remember seeing this X1, X2, Y1, Y2 thing. And if you think back in geometry, you probably remember learning at least 2 or 3 formulas that actually use them. And they are the slope formula, the distance formula, and the midpoint formula. And at that time, your teacher is actually showing you using this notation right here. So therefore, you can subtract x1 and x2 to get the difference between them and use them to do the problem. Now, however, in the subscript notation, you're actually not allowed to subtract x1, a1, and a2 together because they both represent the same vector but different coordinate. So in the subscript notation, you have to subtract things that have the same subscript. While in the XYZ notation, you have to subtract things that have different subscript. So it could get very confusing. As I said, you just have to pay attention to how it's being used. It's not difficult, just you have to get used to a notation of it. Good? All right, maybe just a few more things, and then I would like to stop my video for today. So the next thing is, remember I mentioned to you that when you look at this picture right here, notice that the point 1, 2 is actually the same as the vector x, which is also 1, 2. And there's a reason for that. The reason for that, for now, I can only explain is this concept, and we'll expand on this concept a little bit more. If a vector can be used to define a position in space. And when you do that, this vector has a name. it is referred to as a position vector. Position vector. So a position vector is used to identify a position in space. And how does it do that? So what happened is the following. It will first start with what we call a point of reference. And we cannot actually define a position in space without a point of reference. It is essential to how to define any position. And without a point of reference, you won't be able to identify where you are. So a point of reference for us very likely is the origin. But it can technically be any point. And for those of you who study physics, will probably remember learning something called reference frame, where the point of reference actually move. So how does a position vector work? So let's say I define this position vector. So here's my position vector. And we'll call this position vector x. And we'll define this point as the end of the position vector. And if the position vector is actually equal to, let's say, AB, then that would basically define a horizontal distance A and then a vertical distance B. So therefore, when you have a vector, position vector, like in R2, then the first number will indicate how far to move left and right, and the second number indicate how to move up and down. If you have a position vector in R3, that will be first in the X direction, then in the Y direction, then the Z direction. And so this right here will be a point, and sometimes we refer to this point by name. So in this case, I can call this point point A, which just so happen also has the position coordinate A and B. And yes, in this and so far, this position or coordinates and this position are actually the same thing. They're not going to always be the same thing later on, but for us right now, they are. Good. And so I think we can stop here for now, and we'll talk about some more about vector next time. All right, talk to you guys soon. Bye.